We're going to look at nanotechnology, and in particular ferrofluids. Nano is the prefix for 10 to the negative 9 and is approximately the size of, we're looking at most ions, small molecules, and it's the smallness of the particle that makes the application so important. And the ferrofluids contain particles that are 10 nanometers, 10 times 10 to the negative 9, which really should be 1 times 10 to the negative 10, of course. And they were discovered in 1963 by a research scientist in NASA who was looking for a way to get liquid fuels to flow in microgravity. And as they went on to solid fuels, they didn't need this technology as much. But then there were spin-offs with the ferrofluid uses. And the impressive way of looking at them, you get these little hedgehogs, the ferrofluid there, with a strong magnet. We just separated the ferrofluid from the magnet with glass. Another image here showing two particular sort of pole ends. And properties of ferrofluids, looking how the height of those little spikes changes with field strength, surface tension of the material, and indeed the field direction. And here's a magnified version of the spikes. And they are solutions. They're colloidal solutions. We'll look at that in a little bit. Of your liquid, so your solvent, often an organic solvent or water, with microscopic particles of metal fragments. They have to be able to be magnetized so they can be controlled by magnetic fields. And if you look at the circle on the right, you can see a magnet being held up against a ferrofluid in the little hedgehog type shape of the ferrofluid. So the inside of computer hard drive uses nanofluids in rotary seals. In MRIs, a Fe3O4 triion tetroxide particles in water used as a contrast agent. In loudspeakers, which apparently get very hot and can burn out, removing heat, cooling the voice coil using a ferrofluid. And you can pause this to look at these two links, which are really quite neat. Gold nanoparticles can remote control the brain. Again, this link is worth looking at as well. And some other applications here. And the bottom one, albeit from 2011, shows uses, potential uses, applications of ferrofluids. And you might want to pause this to look at the difference between regular solutions, something like salt solution, copper sulfate solution, a suspension material that's suspended, and when it's stirred up it just looks opaque, and colloidal solutions which have specific properties, and our ferrofluids are colloidal solutions. So you might want to pause this just to go through that table of information. an activity for you to do. Research 3 areas involving ferrofluids. Describe each briefly, and what's the ferrofluid, what's the liquid medium, the solvent, and what is the solute, the particles usually containing iron. And also consider, if you're a research scientist, which application use of ferrofluids would you like to be involved in, and describe the area and why you choose that for research. And a nice link here with activity sheet, etc., that is again worth investigating for your study of ferrofluids. And with many thanks to Washington International School and Team Science there for their help with the video that is included.